Hey everyone, thanks for stopping in. This part of this video is going to be pretty short. I want to throw in here just momentarily. I want to throw in some testing that I did last week. At the end of the video of that testing, there was some life interruption, so I didn't get to finish the test. I did finish it, but not on camera. Anyway, here's where we're at for today. Just quickly. I've got the 2-gauge cable ran, the batteries are in parallel and secured to bus bars. Again, it's all 2-gauge cable, and this is going to be a challenge. I am working on mounting this switch. It's going to go here. I've got to cut some more down here to allow the 2-gauge cable to come out and connect to this, but essentially this is going to connect in here, and then right beside it is going to be a push button and a light, and behind here of course will be a resistor, and that's going to be the pre-charge circuit for when I get ready to turn on the inverter, so I'm not slapping the input filters with a hardcore surge of current. You just make it last longer. Just overall, just a better idea. You don't have to do it, but it's what I choose to do. Then over here, I already have. This is the remote. You will see it in the testing video from last week. So it's going to be here, and right now I'm working on. This is the PZEM 5.1. It's going to go directly below here. I have some AC outlets coming that's going to go down this side, right up here, just below where this stackable part works, where it's located. And so there'll be 3 AC outlets down here, and also down in this general vicinity is going to be an exhaust fan. And over on this side, also similarly located, will be a louver mechanism. I've got, actually this is just a soffit vent, and it's going to go down in this general vicinity. It's got a screen to keep insects out and that kind of thing, but anyway, it'll draw air in through this louver vent and go across the inverter. So an inverter, when I get it mounted, is going to be roughly in the middle here, and I've got some PVC board 1/2-inch thick that this will be mounted to and secured up here to the wall. So that'll stiffen everything up. And then I've also got the charge controller. This is an MPPT charge controller. Let me dig it out here. This is just a no-name MPPT controller. It's a little 20 amp. Let's see if we can focus. No, probably not. Anyway, I'll just read it to you. Rated voltage is 12 or 24 volts. Rated capacity is 20 amps. The max PV voltage, the solar panel input voltage, is 50 volts. And the input power, 260 watts on 12 volts or 520 watts on 24. So anyway, I have tested this before with these batteries, and it performed well. Nothing to write home about, but well enough. And it's small enough that it will lay right down in here, and the lid for this enclosure will fit down over, so it won't right now with all my junk in here. I'm going to I'll post this in the description PDF so you can take a look at it, but and there's no way I'm going to get this cheapy camera to focus on this, but essentially we got here's the batteries, and those are here. The PZEM 051 battery monitor will be down here coming off a shunt, and this is the negative bus bar, this is the positive bus bar. Between these two, I will have some DC connections. I'm going to have a power pole, a 30 amp power pole available, and these will all be individually fused. Solar charge controller will connect to one of these. I've just got it marked in the center here, but I figured on using an XT60 for a connector to come in from solar panels to make the connection. But then I also have I want to put out a 5 volt/12 volt accessory panel where you can charge charge your phone or laptop or tablet, something like that. So we'll put those on there, and I've already got adapters to do the XT60 to MC4. I've got power pole to MC4. I got power pole to XT60. I have all of that available, so whatever I need. I also have what I couldn't find in the previous video. It's kind of hard to see here, but this is a 50 amp Anderson style connector, and essentially, if I need to plug in a high current load of some sort, I want to try to find a place to. These are panel mount version of this, and let me pop that off there. This is difficult to do one-handed. Anyway, so I have several of these, and these will go up to 6-gauge wire, and I've got all the connectors for them and so forth. Anyway, I want to try to have at least one high current input or output. So I have no idea what I use it for, but just in case, I want to have it available. I may not have room for it in this case. I don't know. So anyway, continuing on, we've also got a breaker. I've got the master on-off switch, and I'm showing a breaker over here next to the inverter. That's, of course, you want your breaker closer to the battery. So there's actually a 150 amp fuse coming directly off there, and I want to have a breaker going into the inverter. And then it comes out just generic AC outlets. And then the remote, that's this device here. It's just an on-off and light. You can turn the light on or off if you need. And this is just showing the solar panel input going to the controller. The controller will be mounted in the box here somewhere. So it shows it coming up here to this XT60. Obviously that's not quite right. I want to have solar panels, and it's going to connect to the box. And then inside here is this charge controller that will be connected to the bus bar and provide charging. And then, obviously one of those, probably the power pole, I'm guessing. I will have an external charger, I've got a 20 amp LiPo 4 charger that I can just use grid power to charge it back up if I need to. So anyway, I will endeavor to put as many links to everything I'm using here as possible. If I miss something, please comment. Ask about it in the comments, and if I forgot it, I'll look it up and post it for you. So anyway, that's what I got for this time. Enjoy the testing from last week, and yeah, we'll see how it goes from here. I'm probably a few days away from getting this finished up, because I have that golf cart project, putting an inverter in a golf cart coming up, and I got all the parts for it now, so I need to get going on it. Anyway, that's all for now. Thanks for watching. Hey, I'm just out here goofing around today, trying out the camera. Got a different microphone, see what we got going here. I don't have all of the parts I need for this portable generator, but yeah, I'm a nerd and a geek, and all of my notifications on my phone come in the form of Morse code. Here will be some interruptions. Not much to be done about that. Hey, I'm going to wire this thing together, properly fused and so forth, of course, but I don't have all of the products that I have ordered. They're still arriving almost daily. I don't want to, I'm going to be using two AWG stranded wire regular battery cable to make the final connections on this when I build the solar or the portable generator. Until then, I'm going to be using, I have a lot of these kind of battery cables. These are 6 gauge, and I verified, did some calculations this morning, and I can run parallel to 2 of these for each connection that I need to make, and 2 6 gauges comes out to about equivalent of a 3 AWG, and I will eventually use 2 AWGs, so these will be sufficient for testing, especially since they're only a little over a foot long. There's just a hair over a foot long, so there's practically no voltage drop to worry about in this case. So anyway, I want to wire these together. I want to be putting fuses on the positive terminals of both of these. I got a little ahead of myself here, so I want to take that back apart and do it the right way. But anyway, I'm just going to put the stuff together, and then we'll talk about the components as we go and see what I can come up with for a test. So I'll cut out whatever this I can't use or don't think I should use, and then you'll be seeing the rest. Not quite 100 degrees out here today yet, so I'm still drinking coffee, of course. 13 millimeter. These are 150 amp, 150 fuses. Well, I've got this calculated. These are 100 amp hour batteries. It's a nominal of 12.8 volts. So it's going to fluctuate between whatever 14 volts and down to, I'm not sure where the BMS shuts these off, but down around 11 volts in that neighborhood. So I got these running in parallel and supplying a 1500 watt pure sine wave inverter. Even if I max that inverter out, that would come out to, the way I had it calculated, about 117 amps coming out of the combination of the two. So we're going to split across the two, so it's around 58 amps supplied from each battery. And so 150 amp isn't really doing much for me, other than if there's a short circuit, some kind of catastrophic failure. These, let's make sure I can get you in frame. These go right on the post, so everything goes in and out of the battery is going through a fuse. So that's what we're going to put, one on each. I do have torque values for this, and I will employ that when I do the final connections, but for now we're doing it this way. I'm going to get a fan out here blowing on me. Hopefully the noise canceling feature on this new microphone kicks in. Okay, if that's too much noise, sorry about that. But oh man, not quite open quite far enough. This one will. just hit 100 degrees. Good thing we got a breeze going. All right, we're not going to get it done that way. All right, here's a couple of bus bars. These are rated at 250 amps. Comes with some battery connectors, some wire connectors, and some shrink tubing, and also mounting screws, which, like I said, today we're not mounting anything. But let us not introduce Mr. Red and Mr. Black in any kind of physical confrontation. I haven't had anybody calling me Sparky in a long time. And we'll keep it that way. So my ever-evolving plan, let's make sure we got you in frame. I'm going to mount one of the batteries to this post and one of the batteries to this post. And both of the batteries are fused. And then these two are going to go out to the inverter. So it'll be one cable on each. But this will effectively allow me to keep the current carrying capability at or above capacity of the inverter, because I don't want to burn anything up, or cause any other problems today. So that's the plan right now. Oh, I want to do the same thing for the negative side as well. One of the reasons that I use this style of bus bar is, first of all, they're not terribly expensive, and at some point I'll include this in a video where there'll also be a listing to where I buy all this stuff. This also has these small screws, so things like the PCEM 51, the battery monitor, it's a very small gauge wire, and I don't need to connect to these big the stud bolts for the battery connections. I can just connect to one or more of these screws, and it accomplishes the same thing. So it kind of maximizes utility, space available. Now these HumSync batteries, they didn't come with cables. I think they got two sets of hardware, although I think I've done away with the larger set, the studs that go in there. But that's about it. Manual and and the hardware that goes across top. That's it. Like I said, they're a budget battery, so it's all good. All right. Hopefully you can see these are individually fused. 150 amp here, 150 amp here. This is going to go 2 of these to this battery, 2 of these to this battery, and these 2 will go out to the positive input on the inverter. That's why I may have to take the whole thing and turn it this way. In fact, I probably will do that. Yeah, I will say these fuses comes with this rinky-dink cap, and I don't know how they expect you to use that. It's got a little spot in there that just fits over the bolt, but that's not going to reach up there. Even if I didn't have double terminals, it wouldn't reach up there and fasten. I mean, it'll kind of sit there until it gets bumped, and then it'll pop off. So I will probably come up with a different when I connect this all up for reals. I'll have a different way to protect all this from short circuit. That was tight. Yes, I have ratchets. You gotta be careful with this because that is a plastic case you're tightening down against. All right, I'll go get a rat. Because I got to tear this all down after a while anyway and put it away, so yeah. is one of my ultra modern snap-on tools. I don't know if this is from the first year of snap-on production run or what, but it's an old one. Still works great. I took it apart, cleaned it up there a couple of years ago. It works pretty good. Now I do have the master on-off switch. I'm not going to connect that today. I'll just turn the inverter on and off from the inverter. I may try out the remote just to see if it'll work, but when this goes into a permanent installation, semi-permanent, everything I do is semi-permanent, it'll have a master on-off switch, so I can instantly cut power from these batteries. As I have pointed out several times now, they're individually fused, and then they will go through a switch from the positive side of the bus bar on this side of the bus bar. It will there'll be a switch where I can turn it off. I could maybe connect. Yeah, that'd be a pain in the butt. Yeah, it'll be over here on this side. All right, let's get some kind of protection here. Those just need to be finger tight. (101) still drinking coffee. But with a nice breeze, it's only 101 inside the shop as well, so I guess that's good. Now, if you want to see big sparks, have either one of these touch either one of those. We're not going to do that. We're going to do what we can to avoid that. These are the cables that come with the inverter, and I find this amusing. If you're going to run this inverter at about maybe 10% capacity, I could see using something that size. These appear to be about, I don't know, 8 gauge. Looks like maybe 8 gauge wire. Oh, it's got a cute little wrench in there. Yeah, it's got ground wire, actually. But no, not using these. There's a whole lot of people, a whole lot smarter than I am, that figured out that this is, two of these together is just barely adequate. right there is something I'm going to have to learn to avoid. I think, see, when that happens, there's a huge inrush of current to the filter capacitors on the input of this inverter. And while it's designed to handle that to a certain degree, over time, that's really hard on that input circuitry, that filter circuitry. So I'll have to come up with some kind of pre-charge. Here's another little thing. This wrench comes with the inverter, and it's solid metal. I guess if you do those connections one at a time and you only have one connector going into it, you can put that insulator on after you tighten it down, so that when you go to put the second conductor on of the opposite polarity, you're less likely to short between the two. But right now, where I'm doing the dual wire connections, there's no room to put the insulators back on. Therefore, this is just a bad idea. Just overall bad. They could have done some plasti dip on that or something to reduce the chance of shorting out between the two. But anyway, just pointing it out. All right. I'm going to reposition the camera here so you can see the inverter, and we'll see what we can learn. All right, here we are, and where we are, at least in the process of this testing, you saw me connect the batteries, the little spark, actually it's a good size spark. I have not powered it up yet, but I have connected the remote to that will eventually turn it on and off. In fact, that's how I'm going to probably turn it on this time. As soon as it's on, we'll make sure it's going to work. I mean, just sit here, idle, whatever. We'll see what the meter tells us. Now over here, I've got a heat gun. It is rated for 1500 watts, but there's a low and a high, so I'm assuming the low side is around 750. I don't know, I've never measured it. But we'll start out, once we have it up and running, once we have the inverter up and running, we'll start out with the heat gun on low, and we'll see what the meter tells us. And then when the time seems right, I'll go ahead and go to the high side and see if it'll handle the, it's at the rated value, so it should handle that. This inverter is supposed to have a maximum or a peak value of 3,000 watts, so it could handle, you know, an instantaneous change to 3,000 as long as it goes up and comes right back down without tripping it off. So with the short cables that I've got, an adequate diameter, total diameter of the cables, I would think it would be adequate. So let's see what happens. It says we got 13.8 coming in, 121 volts going out with 0 watts. It says the battery's full. Yeah, 13.8. Yeah, I'd call that probably pretty full. I did do a charge on these. I did another video here recently where I was testing a charge controller, solar charge controller, and I ended up getting a pretty full charge on these batteries. So I believe that it is actually pretty full. So let's go ahead and kick this heat gun on low. Kind of a pain doing this behind the camera. Try to get this so you can see it. 120 watts. Voltage stayed at 121. It does have the little, that's a horrendous noise. It does have the little sine wave symbol up here. So I wasn't going to bring a oscilloscope out here, but I suppose I could at some point. I think I'll probably do that a little bit later. Voltage, battery voltage has dropped to 13 volts already. Alright, I'm going to go ahead and take this all the way up. Drop the battery voltage to 12.3. 1430 watts. And the fans have come on. I don't know if you can see that little symbol right here. It says the cooling fan came on. I don't think this thing would run a whole long time at full tilt because it's already dropped to 12.2, 80% state of charge. Let's go back to the low side. Battery voltage came back up a little. We'll turn it off. Now, as soon as I turn the heat gun off, the symbol for the fan's going away, and I don't hear, oh, yeah, fan's still running. Okay. It comes on. It's a little noisy. I don't know. I guess if you had this, let's say you were using this in an RV, you added its own little compartment, it would be fine. But if it were anywhere in the cabin, it's kind of noisy. Not sure why it's cycling on and off, but all this is, as far as the remote control, is on off and whether you turn the light on or off. The voltage, battery voltage, is recovered now to 13.3. It says it's 100%, which it obviously isn't quite. What I don't have hooked up, which I suppose I could hook up, is the battery monitor, the PZEM51, which will be installed. So let me hook that up and we'll just see. I'm going to go ahead and turn this off. I'm going to put you on pause while I hook up this battery monitor.